Now we're going to talk about the one sample mean hypothesis test and how to perform it. We're not going to get overly complicated with context. We're just going to learn how to do the test. So the givens for this problem are the value of y bar is 8, and the expected value, the mean of the population we believe to be 10. Well, let standard deviation be 2. That's standard deviation of the sample, by the way, and the sample size is also 10. So the null hypothesis is stating that 10 is what we're expecting to see, and if there's no real significant difference, the mean will be similar to that. And I'm asking, with the value of 8, is there evidence at the 5% level of significance that the true value of the mean is now less than 10? I guess I should probably fix that up, huh? This should be also 10. These values are always the same. Now the formula for the one sample t-test has to be put together from the parts on page 3 of your formula sheet. So it's always going to be the statistic or the estimate. I'm going to call it the statistic here because this is the one that supposedly we computed. Whoops. Okay, well, clearly I cannot spell. So let's try that again. The statistic. And then we're going to subtract the parameter. And all of this is divided by the standard error. Now, in Statistics 151 and 161, the formula sheet has these on page 3 in that table. You need to put them together. To do it correctly, you should end up with y bar minus mu divided by s over square root n. Okay, let's put the numbers in and see what we get. This is 8 minus 10. This is 2 over the square root of 10. A little bit of arithmetic. This becomes 2 over 3.16. The square root of 10 is very close to pi, which makes it easy to remember. At the end of the day, though, our test statistic is t on 9 degrees of freedom is equal to negative 3.16. Degrees of freedom, by the way, for the one sample t-test is the sample size n minus 1. And this, by the way, is how you would report the distribution of the test statistic under the null hypothesis if you were asked to do so. Now, what's our conclusion? We need the p-value, or at least a range of p-values, so let's go to a t-table and have a look at that. So the t-table, row 9 corresponds to our degrees of freedom, right here. And you'll see that our p-value, or pardon me, our test statistic t, is between these two numbers. So we're going to go to the top. This is a one-tail test. So our p-value, whatever it actually is, we'd have to use software to determine it, is bigger than 0.005, but smaller than 0.01. Now let's go back to our problem. Since our p-value is less than our level of significance, we say this provides evidence to reject the null hypothesis at the 5% level of significance. And that's really all we have to do for a one sample mean hypothesis test. We'll do more examples in further videos and show some other configurations of this type of problem.